Okay, guys, so I'm going to talk and record this so we can put it on Canvas for kids who aren't here. But the first thing you always got to know is your eye level, right? And so I've measured down 1 inch from the top, and I'm just matching the line that I already have underneath. But I've decided that my eye level is right here. And then I'm just going to use a triangle, maybe, to put in a line of sight, which I'm just going to put my line of sight somewhere in the middle of the page. The one thing that's different for us as artists is, as opposed to video games or photography or television, with photography, video games, and television, this little X is always in the middle of the screen. Like, you can't get away from that. So if I was taking a video and looking around, that X right here is always in the middle. As an artist, we cheat, right? I can say I'm going to move it up and I'm going to draw down here. And maybe I don't even include this in my final. Like, if I made this beautiful drawing down here, I might crop out this and just focus on down there. As an artist, I can do that. Cameras can't do that. Cameras always have that. What's it called in video game? A heads-up display. The heads-up display always, the X is in the center of the screen. So that's one thing that's different for us. Okay, so I have my eye level and my line of sight. And again, in 2-point perspective, your eye level and your horizon line are always the same, unless it's that vertical example I showed you.
Wait, what do you use to measure?
For which one? So I just use my ruler to measure down 1 inch from the top of the page for my eye level.
No, for
the line of sight.
No, what's it called? One to the left with the cross. Where you intersected.
Over here.
Yeah, do you use the 30?
I haven't done that yet. This was from last period. I'm actually going to use it, but don't worry about what's going on over here yet. We have a few things we still need to figure out. For example, station point. I got to decide how close am I to this picture. And we just know the closer you get, the more weird it looks, right? And that's why I almost always just put my station point somewhere down here as far as I can. Because what that means is more of this page will be in the cone of vision. I could take this dot and I could put it clear down here if I really wanted to. But what that does is that also pushes my vanishing points way further out. And so this just seems to be pretty manageable. Okay. So again, it was arbitrary, but I just decided I want to make it look like I'm standing as far back as I can. Right. And so I put that down at the bottom. And then I'm going to use my 30, 60, 90 to put in my cone of vision. And again, this just tells me that whatever's inside of this is going to look less distorted, right? So it helps me decide where to put my drawing. And so we always put it in. Did I draw a cone of vision when I showed you that painting? No, I didn't have a cone of vision, but was I aware of it? Yeah. And near the edges of the painting, I was a little bit outside the cone of vision, and so it got a little distorted. But I'm going to do an activity with you as kind of your final, where I'm going to give you a printout of there's this really cool painting I found of a Dutch master it's not of a Dutch master, it was by a Dutch master, but he has a checkerboard floor in this room and people sitting at a table. And you're going to reverse engineer the vanishing points and the station point And you can take this logic and go backwards. So something to look forward to. But this is my cone of vision from here to here. It's 60 degrees. It's the COV. And this is my station point. Obviously, if I was going home and making a painting, I'm not going to write these things in. But I keep putting them down, and you should too, until they're just embedded in your brain. Okay? So now I have to decide a couple different things. I can decide where my vanishing points are, right? So, and you can be arbitrary with your first one. I can just say, I'm going to pick a spot somewhere for my first vanishing point. And it's going to be, I'm just going to put it right here on the edge of my page. And I'm going to label this vanishing point 1. And I just picked that spot. You can be a little bit arbitrary. But the second vanishing point has to be 90 degrees from the station point to wherever it is. And so I need to get out my 45, 90 triangle. And I put the point. Did I lose you? For the first one. So I put my first one down. I just put a dot there. And now, to figure out where my second vanishing point is, that I know has to be 90 degrees in the other direction. Does that make sense? Vanishing points are always 90 degrees from each other from the station point. Okay, it comes back. I feel like I lost you guys. Yeah? Let me show you why it works real quick. Okay, so look up here real quick, guys. Watch this. Take a break. Let's make sure we understand why this works. So when we were doing 1 point perspective, a cube, the top of the cube, right here. Can you guys see this okay, Thomas? Watch. Okay. This top of the cube, as you move down the eye level, you see more and more and more of it, right? When you get to the station point, it's no longer in perspective. It's like it's on the floor and you're looking straight down at the top, right? Which means that this space, perspective lines are actually real lines, right? And so I know that this corner is a 90-degree angle, right? Squares have 90-degree corners. And so down here, basically what we're changing, in 1 point perspective, this was closest to us. In 2 point perspective, we're rotating it. So now it looks like this, right? But this is the point right here where it's a right angle. And when we move it up, it's no longer appears to be a right angle because these start to go to vanishing points, right? And so when I decided this was my first vanishing point, basically what I'm saying is down here at the station point, that's where this line goes. And so in this world, this cube is rotated that way. And if I change it, I could put it here, but that means I'm rotating the cube as well. And so right now it's going like this, but if I move the vanishing point this way, it changes, right? See how it changes the vanishing point? And so I just picked a spot and said, we'll go with this. But every time you change this, you also change that, right? They rotate away from each other. And they're always rotating away at 90 degrees from the station point. So if this vanishing point is here, this vanishing point has to be 90 degrees from that because we're drawing a 90-degree object. So if this is my first vanishing point, I'm going to put this in. I'm going to draw this line. I'm I'm going to connect the vanishing point with my station point. Okay. The vanishing point 2 has to be 90 degrees from vanishing point 1, from the station point. So this is where I'm saying my cube is rotated. And if I change it, I can, but that means I also have to change the other one, right? They rotate together. If it doesn't make sense, try to follow the procedures. It'll make sense the more you do it. It'll start to. Okay? So now I know where my next vanishing point's going to be. It's going to be this way, but I have to extend this line out a little further. And where it intersects with my eye level, I'm going to erase this old one if I can. That's from earlier. This isn't my vanishing point. This right here is my VP number 2. Okay? And this is because it's 90 degrees from the other vanishing point. Does that make sense? So now I have my 2 vanishing points. I can create this world. And I could put this cube anywhere in here. And as long as this is going to that, these will go to that. You with me, Grant? Okay. So this is my world that I've created. It's just dirt on paper, but it's going to feel like it's an environment that we could walk into. Next thing I need to decide. So we always start our drawings in 2-point perspective with this front corner, figuring out where this front corner is going to be, right? And so in this case, we're drawing a checkerboard. And we are going to draw some dimensions to it, but I'll probably add those in after. So I think what we'll actually do before I draw that corner, we need one more thing. We need a ground measuring line. And that's going to tell us where the front corner is going to be. So hopefully I didn't lose you on the ground measuring line yet. But I just got to decide, we're drawing a checkerboard, and I need to decide where is this front corner going to be in my drawing. And that's what the ground measuring line kind of determines, where that front corner is. And I'm going to make it 3 inches from the bottom, just because that's easy math. So three inches from the bottom. I'm going to put my checkerboard somewhere on this line, the front corner. Okay, so this is the GML, the ground measuring line. This is the line that represents where I know what things measure out, like what size things are, okay? I did it 3 inches from the bottom. So I just measured up from this bottom corner. I went up 3 inches and put marks on either side and then drew it across. But it doesn't matter as long as it's perfectly horizontal. Whatever you need to do to get a nice horizontal line here. Because if it's twisted at all, it's going to throw off everything else. Okay. Now that I have this, I can decide where the front corner of my checkerboard's going to hit. And I'm just going to put it, I'm just picking this randomly. I'm going to say the front corner of my checkerboard is going to be right here at this spot. And I just drew a little dot. Maybe I'll zoom in just a little bit here. That's going to be my front corner. And so it's like my checkerboard. The front corner is right. It'd probably be something more like this, but that's where the corner is going to touch. Okay. And so now I can put in this bottom edge of my checkerboard, because I know that one side of my checkerboard is going to go to my vanishing point 1. So this is one edge of my checkerboard, and then the other edge is going to go over here to my VP number 2. And I know it's off the page here, but I'm going to VP 2. It's this dot right there. As my hand was in the way, this dot right there. Okay, so this is one edge of my checkerboard. This is the other edge. Okay. What I don't know so far, right? There's logic here, so there's things we know, there's things we don't know. I don't know where the back of my checkerboard is yet. I don't know where the rows are or the columns, right? That's what we need to figure out next. But I know where it's laying on the ground. The checkerboard's down here, pretty low, okay? So to figure out the rest, stay with me on this one, guys. You're going to need this information. I appreciate you working and helping each other out, but Taylor, I want you to pause and just watch for a minute, because this is important. So I know that a checkerboard has 8 rows and 8 columns, right? So on this ground measuring line, I can decide how big are they in reality. So it's almost like I'm planning out my checkerboard as if I took this cube like this and I'm twisting it this way, so now I can measure the sides actual like measuring, not in perspective, because in space they're going to get smaller every time, right? So at first I need to figure out how big are they if they're not in space, if they're just lined up on this. And so what I'm going to do, I have about 5 inches to the end of my paper, so I can't make them 1 inch. So maybe I'll make them 1/2 inch. And so what I'm going to do is on this ground measuring line, I'm going to measure out my 8 columns. It's as if I'm taking my checkerboard and just lining it up, right? So 1/2 inch, there's 1 row, 2, 3, 4, 5, 6, and then 7, and then 8. So if I took my checkerboard and just lined it up and turned it into a 1-point perspective.
You want us to do that? Is this 1/2 inch?
I did 1/2 inch.
You want us to do that?
Does that work for you to follow along, or would it be better for you to?
Follow along.
Okay, so go ahead and do that. And then do it on the other side too, because we got to measure the other side. So it's like, what's that? Well, there's 8 spaces.
So 8 on each side?
There's 8 spaces between the dots, so technically that's 9 dots. But the middle dot counts. And so I got to go the other way as well, though. So you should have, going away from this center, if this is 0 on a number line, you'd go 1, 2, 3, 4, 5, 6, 7, 8, and then -1, -2, -3, -4. Does that make sense, Grant? You can say no. I won't hurt my feelings. If you're like, what the heck is this guy talking about? So I've got 1 space here, 2, 3, 4, 5, 6, 7, and then 8. Okay, so on the ground measuring line, this is what these actually would be. Do you guys need a second to keep going, or are we there? Okay. So now what we need to figure out is how do we measure how these would get smaller as they go into the distance. And that's where we need something called a measuring point. Okay? And so again, if you don't understand the logic of this, it's okay. I'll try to explain it, but if you know the procedure, you can still make the image without understanding why it works. Sometimes it's like that in math, right? You learn this equation, and if you follow the equation, you get the right answer. Hopefully, eventually you understand why it works and what it means. But you kind of have to learn the procedure and the concept. And I've got a scrap of paper here that I'm going to use. But what you can do is you can measure from your station point to your vanishing point. And this is my VP1. I don't know why I put 1 on this side and 2 on that side. It doesn't matter which one's which, but it matters that you have the measuring point that goes with it. So since this is VP1 and this is the distance, this swings up like a door, right? So keep this dot on the vanishing point and swing it up. And where that swings up to, you put a dot, and this is VP1, so this becomes MP1. And then you do the same thing with VP2. So again, find that measurement, the distance from between the vanishing point and the station point, and it swings up like a door. You can't teach art and not do sound effects. So here's my measuring point 2. So I have a VP2 and a measuring point 2, and I have a vanishing point 1 and a measuring point 1. It's not hard to get them, right? You just follow that step. So you take your vanishing point and your station point, and then you swing it up and put a mark on the horizon line. So to use ground measuring lines, it's all about swinging like a door. Swings open, and I'll show you how it works. But for now, just make sure that your vanishing point is the same distance from your station point and your measuring point. This distance is the same from here to here and from here to here. And then your VP2, it's the same and the same. So what's that called? Is that an isosceles triangle? You're basically creating an isosceles triangle. 2 equal sides and then a different one on the bottom. Show me when you have it. Crew, you and Dylan getting this? Put your phones away. This is pretty important. If you don't get this, nothing else from here on out is going to make sense. And even if it doesn't make sense, as long as you know the procedure. So, how to find the measuring point.
From the dots, which line do you connect it to? Or which, like from each dot on the ground measuring line, where do you connect the line to?
That's what we'll do next. Okay. So guys, for the sake of the video, I'm going to continue, and I want you guys just to watch. If you're caught up and you want to follow along, that's fine. If you're kind of lost, watch. We'll have next class period for me to come around and help you individually. But I want to make this video, so this line here, this corner of my checkerboard is going to vanishing point 1. So if I want to measure from my ground measuring line for a line that goes to VP1, I use measuring point 1. Super important that your line, your vanishing point and your measuring point are working as a team. So this is a line that goes to vanishing point 1. I know that if I rotated my checkerboard so it hit the ground line, this is where the first row would hit, right? And so measuring point 1 to that dot tells me in perspective if I swing this dot up into space, that's where it's going to hit. And that's what I need to know for my drawing. I need to know this line goes to my measuring point. Where it hits that line, that tells me where my first row is going to go. And then I keep using measuring point 1 and I just go to the next one. Till it hits that line, and that tells me where my next row is going to be. In 2-point perspective, it's hard to distinguish between rows and columns. But I guess, are they both rows? Not that that matters. Just terminology-wise, I'm curious. So anyway, I can go through and do all of these. So if I want to know where the back edge of my checkerboard is, I can go to this one. These lines will not be a part of my final drawing, so I want to draw them really light. They're measuring lines. And I just need to keep extending all. Each time I check and I make sure that I'm hitting my measuring point. Sometimes your ruler slides a little bit, so you got to make sure you're good. But again, just right where it hits, right where it hits. That one was a little off. Start again. Again, that's where that one hits. And if I was actually drawing this, I wouldn't draw this whole line. I'd just make a little X right on here. But just so it, hopefully it makes sense where these lines are coming from. So all of these lines are going to measuring point 1, okay? And once I know these distances, now I can take these distances and go back to vanishing point 2. And these are actually part of my drawing. So these are my rows for my checkerboard. Does this make sense? So this measuring point tells me where to start the line, but then I have to go to the vanishing point, right? So this line measures, but this line actually is the checkerboard. So I know where all my rows are now. I just have to draw them to the vanishing point. And I'll zoom out. So my vanishing point's here. These are all going to my vanishing point. There's a lot of places where this can get a little confusing. So ask questions if you get a little off. Okay, so can you start to see my checkerboard appearing there? Yeah. This is the edge, and this is the rows going back this way. So I can show you now, I could find my back corner. So this line is my goes to vanishing point 2. So if I want to measure on vanishing point 2, I use measuring point 2. But I know that this is the back edge. So if I want to find where that swings over into space, I go to measuring point 2. And again, this line doesn't tell me the direction, it just tells me where that line starts. Then once I hit that line, I have to go to the vanishing point. And this is the back of my checkerboard, because I started from the outside. But this is where my checkerboard ends. So my checkerboard is going to exist in that space right there. Do you see it now? And so I just got to figure out where each of these rows are going to hit. using my measuring point. So again, if the line that we're measuring on goes to VP2, then I have to use measuring point 2. So my first column, or if the other side was rows, these would be columns. So the first one's gonna hit there. Second one's gonna hit here. Helps if you have a nice sharp pencil. Do you guys notice something different between a 2-point perspective checkerboard and our 1-point? Other than just the perspective's different? It's a lot smaller is what's standing out to me. Our 1-point perspective checkerboards were pretty big. This checkerboard's pretty small. And we could have made it bigger, but that would have involved having my ground measuring line going clear off the page. And again, are these lines going to be part of my drawing? They are not. These are measuring lines. These are just to help me figure out how things are going to appear in perspective. Okay. And so now I know all the points where my columns are going to go, and I can start drawing those in. So here's my first row, or column, whatever. And that goes back to there. There's my next one. So a 2-point perspective involves a little bit more work because you have to do a lot of measuring before you can actually start extending your lines. Where in 1-point perspective, you don't have to measure half of your lines, right? Because they already, like the front of your checkerboard is the ground measuring line. So I guess it's twice as much work. Okay, guys, so here's my last row or column, and there's my checkerboard. And so now I can come in. I don't need a lot of these lines anymore. I can start to clean this up. Now we want to add thickness to this, because we want it to fill 3D, not flat. So we have to make a choice here. We could say, well, let's make it 1/2 inch taller and start at our ground measuring line and bring it up. But then we'd have to remeasure everything, right? And so just to make it easy, remember in 2-point perspective, verticals stay vertical. So I can actually drop down and just add an arbitrary thickness, and as long as I keep my verticals vertical, I can drop these all down and I can make it fill 3-dimensional pretty easy without doing any measuring. So the bottom of my box is going to go to the vanishing point. We don't want to just have these 2-dimensional. We want them to appear 3-dimensional. So what I did, again, to get this 3-dimensional quality, I just dropped the vertical line down from this corner, and I was arbitrary. I didn't even measure it. I just said, it looks good if it's that big. And then I take that back to my vanishing point, and then as long as I keep these vertical, I probably should be using my triangle for this. But now I've got that 3-dimensional feel to it. Do you see that? Verticals stay vertical, so I don't have to measure anything. I could use my triangle like this, and I just know where this line hits this corner, then it's got to drop down vertically, right? And so I can use my triangle to make sure I'm vertical. And there's a drop down. Make sure to erase out the measuring lines because they might get a little confusing if they're competing. So if you look right in here, some of these lines we don't need anymore. Don't need that line, don't need... I need to get one of those little mechanical pencil erasers. Oh my gosh. Okay, we will work on these next time.